This video is supported by Brilliant.org. There are really only three things about time that we don't understand: the past, the present, and the future. Because the past once existed and now does not exist, the future doesn't exist, and the present, well, you can never really catch up to it. Like right now, you're watching this video, and in the future of this video, I'm going to do something that you've never seen me do in a video before. And that tease that I just did is now in the past. And the present is right this very moment. And ironically, by the time you've even processed that moment, it's already in the past. The passage of time is perhaps the biggest guiding force in our lives. We celebrate it, we mourn it, we schedule our lives around it. The very passage of time is the thing that makes our existence possible, and it is also the very thing that will eventually take away our existence. So it's no surprise, given its importance, that a lot of brains have worked on what time is over the years, and we've got a lot of different interpretations of it. And still, what exactly it is and how it works remains a mystery. The Christian monk St. Augustine was once asked, "What is time?" And his response was, "If no one asks me, I know what it is. If I try to explain it to him who asks, I don't know." Pretty accurate. And it's one of those things that you think the more we study it, the more it would make sense, but no, it just becomes more and more hard to understand. Insert Doctor Who timey-wimey reference here. And our study of time goes back long before we even have records. The ancient Egyptians used obelisks as sundials to tell what time it was during the day. They also had water clocks that flowed at a steady rate to keep time, and obviously hourglasses. It was the Babylonians that first divided the day into hours made up of 60 minutes each, which were divided up by 60 seconds each, and they did this all the way back in 1800 BCE. It was the great Dutch astronomer and physicist Christiaan Huygens who first invented the pendulum clock in 1656. This was actually the most accurate way of keeping time for the next 300 years. 1927 saw the invention of the first quartz crystal clock. This uses the piezoelectric properties of quartz that vibrates at 32,768 hertz, giving it an accuracy of 6 parts per million. But the most accurate measure of time we've been able to conceive so far is the atomic clock, which uses the natural resonance of the cesium atom. This makes the current definition of a second the time it takes a cesium-133 atom to vibrate 9,192,631,770 times. Ain't no way I was going to memorize that number. And this is important not just as a measure of time. The cesium standard also helps define other SI measurements, like the meter, which is the length it takes for light to travel in 299,792,458th of a second. I should have that memorized by now. Of course, we don't need a clock to feel the passage of time. We actually have our own little internal clocks. One of them you might consider would just be the heartbeat, which beats at an average of around 70 beats per minute. And then there's our circadian rhythms, which comes from the hypothalamus. This kind of secretes hormones at different times of day, giving us wake and sleep cycles. But our perception of time is subjective. As we all know, time can feel like it's speeding up or slowing down depending on the situation. It tends to slow down quite a bit when we're in danger or in some excitement. So it was believed by many philosophers over the years that time is completely subjective and that there is no objective absolute time. This is one of those things that was vigorously argued by guys with long beards standing around marble columns and stuff. But as the scientific revolution began to take hold, this argument sort of fell away and it became replaced by an argument between what you might call relationalists and absolutists. Absolutists believe in absolute time. They believe that time is an independent constant of the universe that functions independently of our perception of it or by the interaction with matter. Sir Isaac Newton was one of these absolutists. The relationalists saw time only as a measure of change, basically arguing that the only reason time exists is because of changing states of matter. So theoretically, if you had a walled-off room where nothing happened inside of it for millions of years, technically time did not pass in that room, which is kind of weird. But it's actually not that far off from the definition of time as a measure of entropy. Newton's second law of thermodynamics states that in a closed system, entropy will always increase over time. Entropy being the state of constantly moving toward equilibrium. So if you have a hot coffee sitting on your desk, the heat from that coffee will dissipate into the surrounding environment until its temperature reaches equilibrium with everything around it. It doesn't go the other way. Another example might be a wine glass. It is in a state that is definitely not in equilibrium with the rest of the world. Wine glasses aren't naturally formed after all. But if you shatter the glass on the ground, all those little pieces are much closer to what you might find in nature. stomp on them and they get smaller and smaller. And if you smash it on a road where cars drive over it over and over again every day, it'll get even finer and finer, smashed down into dust, which is an even more even texture. And if you want to keep going with it, someday when the sun expands, it'll vaporize this and it'll just become gas dissipated out into the universe. You get the idea. But the arrow of time only travels in that direction. That wine glass is not going to just reassemble itself. By the way, another interesting way of looking at entropy is through the statistical mechanics model that was championed by Ludwig Boltzmann. He made the point that if you had two boxes with 20 balls labeled 1 through 20, there's only one way for all the balls to be in one box and not in the other. Whereas if you had a 19-to-1 distribution, there are 20 ways that could happen because there are 20 different balls that could possibly be the one ball in the other box. Extrapolate that up to a 15-5 distribution and there are 15,000 different ways that could be arranged. So a 15-5 distribution is 15,000 times more likely than a 20 and 0 distribution. In a 10 and 10 distribution, there are more than 180,000 different arrangements that could make that happen. So statistically, if you randomly distributed the balls, there was a much higher probability of a 10 to 10 or an 11 to 9 distribution than a 20 and 0 or a 19 and 1 distribution. Now, if you apply this to atoms and energy, the same rules apply. Atoms in the air are going to randomly collide and interact with each other, and they're going to sort of spread themselves out and distribute themselves evenly throughout your house so that one room isn't going to have a higher pressure than another room. Now, where this really gets interesting is that Boltzmann predicted low entropic fluctuations. So what does he mean by that? So if we go back to those boxes with the 20 balls in it, the probability of getting 20 and 0 are incredibly low, as we talked about before. But if you run that over and over and over again, randomly distributing them each time, eventually, after millions and millions of times, a 20 and 0 combination is going to happen. That's just how randomness and probability work. And that is a low entropy fluctuation. So take that and expand it out to the enormity of our universe, and you can expect that at some point in time, that there will be a low entropy fluctuation in the universe, meaning that time will actually travel backwards, flowing toward a lower entropy state. Boltzmann actually believed this was an explanation for the Big Bang, although that idea has now been discredited over the years. Now, there is a more philosophical debate about the nature of time and how it actually progresses, and this falls into two camps of tenseless and tensed theories of time. The tense theory of time states that the future does not exist yet, that there are branches of time that kind of spread out as time progresses forward, but it's created as it goes. The tenseless theory of time states that the past, present, and future are all equally real, and we are just traveling along that timeline on the now. Deterministic? A bit. Lacking free will? Yeah. A whole other can of worms that I won't get into here? Absolutely. Of course, time was always considered to be an independent force in the universe until Einstein came along and realized that time and space are two sides of the same coin, that coin being, of course, space-time. Actually, to be fair, Einstein was one of two people who came up with this theory of space-time, the other one being Hermann Minkowski. Einstein stated in his 1905 paper on special relativity that the laws of physics and the speed of light must be the same for all uniformly moving observers. And for this to be true, space and time can no longer be independent. This was the only way for the speed of light to be constant for all observers. But it was Minkowski 3 years later who came up with the idea that space and time could be seen as a single four-dimensional space-time fabric. He closed out his paper on the subject by saying, "Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality." Minkowski, by the way, was famous for using what he called light cones to show how an object travels through its world line in space and time. So now we know that space and time are connected. Here's something else that we know. The universe, and all of the space that encompasses it, is expanding. We know this because the further away a galaxy is, the faster it's traveling away from us, and that's because the space between us and that galaxy itself is stretching. And the force behind the stretching is what we call dark energy. Dark because we have no idea what it is. So could it be that since we know that space and time are connected and that they are expanding, that what we perceive of as the forward motion of time is in actuality simply the expansion of space-time? And if we came to understand dark energy and were able to reverse it, would that actually constrict space-time and in effect reverse time? And this leads me to one of my biggest pet peeves about the way time is portrayed in TV and movies, because you always see it as if someone is just kind of leaping from one time to another, like in Back to the Future, where it doesn't make sense when you think about it, because if time and space are connected, then you're not just jumping to another time, you're also jumping to another point in space, which is basically teleporting. And nobody ever talks about that. So, I mean, consider that the planet is revolving at 1,600 kilometers an hour. So if you went back even 5 minutes, you would wind up like 130 kilometers off of where you started. But it gets even crazier than that, because the Earth is also rotating around the sun, and it's traveling like 30 kilometers a second going around the sun. So you would wind up like 9,000 kilometers off from where you started, which means you're either stranded out in space, or you're like buried in the mantle and like vaporizing underneath the crust of the Earth. Bad situation, either way. But actually it gets even crazier than that, because the sun is traveling around the Milky Way at like 230 kilometers a second. So you would wind up like 70,000 miles off course from where you started. It's not a good situation. And that's only going back 5 minutes. Imagine going back a day, or a year, or 100 years, or something like that. The level of accuracy you would have to not wind up stranded out in space or buried somewhere deep in the planet, it's almost impossible. There's almost no way to pull it off. So the only conceivable way, that makes any sense anyway, to go back in time is to go back along the same timeline that got you to where you were in the first place. So, what would that look like? It would look something like this. To the outside observer, a person traveling backwards in time would be exactly that, a person in reverse. The perspective of the reverse time person would of course look normal to them, and everybody else would be reversed in time. I can only assume this would have to entail some kind of temporal bubble around the reverse time person that allows this to take place, but by traveling backwards along the same timeline as before, you ensure that you don't get, thrown off the spatial plane as well, and you can just sit there in your comfy chair, moving along through time reversed from the rest of the world. Which, by the way, one might argue this would make you a kind of antimatter, because according to some interpretations, antimatter is simply regular matter traveling backwards in time. Now this is also very limiting because, for one thing, you're moving backwards at 1 second per second, so if you wanted to go back a year, you would literally have to just sit there for a year. Though if we're controlling dark energy, I guess you could just increase the rate of dark energy to compress space-time more and therefore speed faster through time. Another question, though, is would you age inside of this temporal bubble? In which case you could only travel back in time so far before you reach the point when you were born, and theoretically you wouldn't even be able to go beyond that. Ironically, The Time Machine by H.G. Wells, which is one of the very first science fiction stories to involve time travel, kind of got this right a lot better and is a lot closer to what reality would possibly be than a lot of the time travel stuff that we see these days. Now that's pretty fantastical stuff about traveling into the past, obviously, but traveling into the future is totally something that's possible. You can actually do that. In fact, you're doing it right now. Now yes, we are all time travelers in a sense, traveling forward in time at 1 second per second. But if you travel at relativistic speeds, you can actually speed that up quite a bit. As Einstein's general theory of relativity shows, the closer you get to the speed of light, the more your temporal progression slows down, which means that you actually experience time a lot slower than the rest of the world, which means that you are kind of traveling into their future faster. You could say that time keeps on slipping into the future. This is known as time dilation, but you guys know all this. You've seen Interstellar. One last thing I'll leave you with here goes back to that whole how we perceive time thing, because as we all know, the older we get, the faster time seems to pass. This is sort of a universal thing, we all seem to experience it, but there is a reason for it. Because we don't experience time linearly, we experience it proportionally. We interpret time as a proportion of the time that we've been alive. So if you're 4 years old, 1 year is 25% of your life. It is 25% of everything you have ever experienced. That's a big chunk of your life. But if you're 50, 1 year is like 2% of your life, which feels like much less because it is much less. Ultimately, time is a construct that we organize our lives around, but the only time that really matters is right now. No matter what you're doing, whenever and wherever you are living in a perpetual now. The moment you are living right now is the only time that moment is ever going to happen in all of history. So make the most of it. That doesn't mean you have to go climb mountains or make every moment big. It just means from time to time throughout your day, just kind of stop for a second. Just soak it in. They say that depression comes from living in the past and anxiety comes from living in the future. But happiness, that comes from living right now. So embrace it. So much of what we understand about time came from Einstein and his special theory of relativity. So if that's something you've never quite gotten your head around, something you've always kind of struggled with, One place that you can learn a lot more about it is the Special Relativity course on Brilliant.org. This course will walk you through Einstein's breakthrough theory by showing you the kinds of problems that plagued physicists back in his day and how his theory solved those problems. Using fun interactive games and puzzles, this course will give you a deeper understanding of relativity than you ever had before, from the speed of light to the real meaning of E equals mc squared. This, of course, is just one of many courses on Brilliant that will change the way you look at the world. Brilliant is an online learning platform that's different because it doesn't just throw facts at your face, it actually teaches you problem solving so that you can think like a scientist and apply that to all places of your life. And with their new daily challenges feature, you can develop a learning habit to keep that brain growing all throughout the year. You can sign up for free at brilliant.org/answerswithjoe and get access to their weekly brain puzzles and teasers and stuff. And if you like that and you want to go further, the first 200 people that sign up for their premium subscription, which gives you access to all their courses, will get 20% off your subscription for life. Don't just get smarter, get brilliant. Brilliant.org/answerswithjoe. Links in the description. Big thanks as always to Brilliant for supporting this channel, and a huge shout out to my Patreon supporters on Patreon. That's where they are. My answer files, as I call them, they're growing a great community. They're doing great things. They're supporting this channel, keeping the lights on. You want to join them. But I do have some new people who joined. I got to murder their names real quick. We got Tommy Fannin, Rob Christian, Robert Keller, Raging Cactus, Will Cooper, Revel Aiden, Ross McLean, Rasmus Kortshagen, and Lord Greg. My lord. Thank you guys so much for joining, and if you would like to join them and get early access to videos and just be a part of a really awesome community, you can go to patreon.com/answerswithjoe. Please like and share this video if you liked it, and if this is your first time here, I've got a video right here you might want to check out. You might like it too, or any of the others that Google might be suggesting for you down there. I invite you to check those out, and if you do like them, maybe hit subscribe. I invite you to join us because I come back with videos every Monday and every Thursday on fun, science-y, and future topics and stuff. T-shirts available at always at answerswithjoe.com/shirts. Thank you so much for watching. You guys go out now, have an eye-opening rest of the week, and I'll see you next Monday. Love you guys. Take care.